Question number 9 says that a baseball diamond is a square with side 90 feet. I don't know if you play baseball. Not everyone that watches this videos are in America. In fact, only about 30% of you are. But here's home plate in baseball. When you hit the ball, you go this direction, first base. Then you head this way to second base and so forth. And they tell us that it's 90 feet, which is true in professional baseball. And they say that a batter hits the ball and runs toward first base with a speed of 24 feet per second, which is the same unit here. So that's good. We don't have to worry about units. It says at what rate, meaning dt, is his distance from second base decreasing when he's halfway to first base? Okay, well, let's think about this a minute. Oh, excuse me, what was that? Let's reorient the baseball diamond into a square. That's going to be a better choice. We'll set home plate at 0, 0. We'll put first base at 90, 0. And we'll put second base at 90, 90. That's pretty far away. And now I'm going to draw a line to where they're saying that this person is right here. And I'll just say it's 45, 0. This is the information that I see that we have. We'll call this D for distance. Pretty original there, right? And let's see what we can do. So we know that the player's running this way. You can tell that the distance is going to decrease because this distance is going to be 90, and this distance would be a little more, this distance would be a little more. So it should be a negative that we come up with, and they're asking for what? At what rate is his distance decreasing? So that's going to be a dd dt, and that's what they're asking for, like so. And I think the first thing we want to do here is look at this triangle. The player starts here, and he travels, let's call it 24t for a distance. Every second he travels 24 feet, yeah. And we know that this whole distance is 90, which means the actual side of the triangle is going to be 90 minus whatever he's accomplished here, which is x. And this side is going to be 90 no matter what. Second base isn't going to relocate itself. So we can develop an expression for the distance. I think you know the Pythagorean theorem by now. D squared equals a squared, which in this case would be this side squared plus 90 squared. Is that right? That feels right to me. Now, do we want to take the square root? I guess we could take the square root. I'd like to try this without it though, because square roots are hard. And we want a dd dt. Okay, so let's see if we can just do it this way. What if I take the derivative with respect to time like this? I don't know that this is right or wrong, but we're going to try it out. When I take the derivative of this outside function, we need to take the derivative of the inside function with respect to dt. So first x is going to get the negative 1 here, and then it's going to be dx dt. Chain rule, right? And then this is a number, so I think its derivative is 0. I feel like that's true. But leaving out all the y values seems suspect to me. Well, we'll give it a try. We'll see what happens. We'll see what happens. If I get the wrong answer, then you won't be able to see this video. So, let's see, negative 1 and 2. Here's a 2 here. Let's just divide the 2 out. That's one way to start it off. So we could say dd dt equals negative 90 minus x over d, I brought this d underneath here, and then dx dt is here. But we know dx dt. They told us that. That's that's the speed at which he's running horizontally. That's the 24 feet per second here. So we can put the 24 in on the next wave here. And what's d? Well, our triangle gives us d. d is the square root of, this length is 45 and this length is 90. remember they told us where we are in position. So 45 squared plus 90 squared. I feel like that's going to be hard to do in my head. What's 45 squared? I'm going to type it right in here. 45 times 45 is 2025 plus 90 squared is 8100. So if I take the square root of those two together, I get d, well, I'll just write it out on here. dd dt equals negative, here's x is 45, right? So 90 minus x is 45 over 100.623, and this here was 24. So if I take 24 times 45, I get 1080, and I'm going to divide that by 100.623, and the answer that I got was negative 10.733 feet per second. Now, I do believe that is the answer for part A. So what would we do for part B? This worked. Do you notice I didn't have to square root this? I want you to remember that if you're getting good with implicit differentiation and that kind of thing, you should be able to do this without the square root. And who doesn't love that? So how about this one? Well, third base is going to be like second verse same as the first kind of an idea, right? For one other thing is that now the x is increasing in this direction. So if I want to make this triangle, I think what we would say is this would just be x, and this is 90, and this is our d. So we'd say a squared plus b squared equals c squared. Take the derivative with respect to time like this. 2d dt equals 2x dx dt. So this is a time derivative, and the derivative of a number is 0. So we can divide the 2's out. That's dope. And we know x is 45 and dx dt is 24. We saw where that came from. And we can divide the distance out, which is the same as before. I think is still the 100.623. So let's come to that and see what we get here. 45 times 24 is 1080 divided by 100.623, and I again get positive this time, 10.7333. And that should make sense because when you're in the middle here, your distance from this way and from this way, it looks like they're going to increase and decrease at the same rate if you're exactly in the middle, right? So those are the answers to this particular question. And the trick here is to be able to take a derivative off of a square without using the square root, because who wants to do the power rule with all that chain rule crap? You know what I'm saying, Vern? And you're Vern.